Let's have a look at how to install a motherboard. In this video, I'll perform a demonstration of installing an MSI MAG X570S Tomahawk motherboard. I won't be installing other components like the CPU and memory modules, as I will leave them to another video. It's not a bad idea to have a look at the manual before installation. Some motherboards may have additional jumpers, although on modern motherboards this is pretty rare. Once you've installed a few motherboards, unless it's a proprietary motherboard, you'll notice the installation process is pretty similar. Generally, when I look in the manual, I'll first look at the motherboard diagram. This will give me an idea of where everything is. If you're trying to plug a connector into the motherboard and are having trouble finding it, have a look at this diagram. The next part of the manual I'll look at is the section on front panel connectors. As we'll see in the demonstration, these connectors are what connects the computer up to the computer case. This includes power, reset, USB and audio. Now let's have a look at how to install the motherboard. Motherboards are vulnerable to electrostatic discharge, so you always want to take some anti-ESD precautions before installing the motherboard. In this case, I have an anti-static mat. If you don't have an anti-static mat, as a substitute, you can always put the motherboard on the box the motherboard came in. Some anti-static protection is always better than none. Since I have an anti-static mat, I won't need the box. On the corner of the anti-static mat are two grounding points. On one of these grounding points, I will connect a ground cable with an alligator clip. I will use this later to ground the computer case. I will put on an anti-static wrist strap and connect the other end to the other ground point. This will provide a connection between me and the anti-static mat. I will next place the computer case that I'm going to use on the anti-static mat. To install the motherboard, I need to remove the side panel. For this particular computer case, there are two screws at the rear of the computer case that needs to be removed. Once the screws are removed, I next need to slide the panel and lift it upwards to remove it. Your computer case may be different. Some cases do not have screws but instead have clips that hold the panel in place. Other computer cases may have a lot more screws to hold the panel in place. Now that the side panel is off, I can connect my alligator clip to a metal part inside the computer case. There's a problem. You'll notice that as I look around the computer case, everything is painted. In the old days, there was always some metal edge that you could connect your ground cable to. But nowadays, many computer cases don't have any metal points to connect your cable to. The only possible points will be covered by the motherboard when I install it. To understand how we're going to fix the problem, I'll perform a quick experiment. You'll notice with this multimeter that when I connect two terminals together, I get a reading on the LCD screen. This setting on the multimeter is designed to test for a closed circuit. That is, a circuit that lets electricity through. If I now connect the terminals to each side of the screw that I removed from the case, you'll notice that I get a reading on the multimeter. This indicates that electricity can travel through the screw. Thus, if electricity can, so can static electricity. The learning outcome here is that even though your computer case may be painted, electricity can still potentially travel through it. Different parts of the computer case may be painted with different thicknesses of paint. You'll notice that when I put terminals on different sides of the painted computer case, no connection is made. Thus, painted computer cases don't make a good choice for ground cables. Generally, the paint is too thick for a connection to be made. The painted screws have a thinner coat of paint, so I will connect my ground cable to a painted screw still in the computer case. This should be enough to ground the computer case. If you connect the ground cable to a different part of the computer case, you risk scratching the paint. So the screws are generally a better choice if you don't have an unpainted metal edge to connect the ground cable to. Now that I've got my anti-static sorted out, I will next get out my motherboard. When removing the motherboard, I will generally try and hold it from the side and pull the anti-static bag away from the motherboard. Whichever way you do it, just do your best not to put your fingers on the components of the board. You want to hold it by the edges where there are no components if possible. Before I can install the motherboard, I need to ensure there are enough standoffs. A standoff is a metal riser that goes between the computer case and the motherboard. You can see in this example how the standoff elevates the motherboard from the motherboard tray. This helps prevent damage to the components and short-circuiting of the motherboard. My computer case has some standoffs pre-installed. You can see an example of a standoff here. I will need to add some more for this motherboard. When I look around the computer case, you can see the standoffs that are pre-installed. On some computer cases, the standoffs may be fixed and cannot be removed, whilst in others, the standoffs have been pre-installed and can be removed. Different form factors or different size motherboards require the standoffs to be in different positions. The computer case will, therefore, determine which different types of motherboards it will support. When I have a look at my motherboard, there are screw holes for the 6 pre-installed standoffs in my computer case shown in green. I will need to add 3 standoffs shown in red. If you're not sure where to add the standoffs, you can always put the motherboard into the computer and line it up with the screw holes. Once the motherboard is in place, you can see the 3 screw holes at the top of the motherboard. This computer case has a drive bay at the back of the computer case which hangs over the motherboard. When I put the motherboard in, you'll notice I had to tilt the motherboard under the drive bay to get it in. This makes putting the motherboard in harder than if a larger computer case was used. When purchasing a computer case, it's worth considering how the motherboard will go in the case and other components such as graphics cards. For a smaller computer case, it can sometimes be a bit of a squeeze to get everything to fit in. In some computer cases, everything won't fit in unless you get a hacksaw and cut away some of the computer case. Trust me, I've done it before, but I would not recommend it. Just get a computer case that's designed to handle the size of the motherboard and other components you're going to use. I will now remove the motherboard so I can install the standoffs. I will screw in the first standoff by hand. When screwing the standoff in, you'll notice that they are pre-threaded. You only need to screw it in until it's finger tight. When you feel it's got to the end of the thread, stop screwing it in. If you attempt to screw it in any harder, you risk damaging the thread. Also remember, you may want to get the standoff out again one day, so you don't want to get it in too tight. Finger tight is enough to prevent the standoff coming loose during use, and you should be able to remove it later if you need to. To install the next standoff, I will use a nut driver, which is found in most computer toolkits. It's just a matter of putting the standoff in the nut driver and then screwing the standoff in. In some computer cases, you may need to use a little force, particularly if the case is new. This is because the thread may be a little blocked with material or incomplete when manufactured. When you feel that the standoff is screwed in all the way, stop screwing it in. If it's only partially screwed in, try turning it a bit harder. If you're having no luck, remove the standoff and try again. If that doesn't work, try a different standoff, as maybe the thread in that standoff is damaged. The last standoff is a difficult one, since it's under the drive bay. This can only be installed by hand, since the hard disk enclosure blocks the nut driver. Once it's in place, this is all the additional standoffs that need to be installed. The next step would be to install the motherboard. To install the motherboard, the next thing that I would normally do is install the I/O shield. The I/O shield is a piece of metal that is attached to the back of the computer. It prevents dust from getting into the computer and helps with electronic interference. In the case of this motherboard, there's no I/O shield as the motherboard is made to take up all the space of the I/O area. So, we can understand how to install a motherboard that has an I/O shield. I'm going to perform a quick install of a different motherboard. Before installing the I/O shield, I will line it up with the motherboard to make sure the orientation is correct. It's quite easy to install an I/O shield upside down. To install the I/O shield, place it in the I/O area. The I/O shield needs to click into place all around the edges. Push around the edges with your finger. If you're having trouble, you can always use the back of a screwdriver to help push it in and click it into place. It can be troublesome to get them in. If you're having trouble, move around the I/O shield pushing on each edge until it clicks into place. Once it's in place, all the edges should be flush around the I/O shield and the I/O area. That's all edges, not just the corners. In a moment, I will install the motherboard. If you're having problems putting the motherboard in, you may need to bend some of the clips on the I/O shield up. This I/O shield only has one clip, but you can see it's already quite high up, so there's no need to bend it up anymore. Now it's time to install the motherboard. You want to hold the motherboard by the edges and place it into the case on an angle. You're essentially trying to get the connectors under the clips in the I/O shield. Once you've done that, you next need to line the screw holes up with the standoffs. You also don't want to put the motherboard straight down. Even though we moved the motherboard around slightly to line it up correctly, We don't want to drag the motherboard over the standoffs, as this may damage the motherboard. Now that I've shown you how to install an I/O shield, I will now remove this motherboard and also remove the I/O shield. Since this is not the motherboard that I wanted to demonstrate, this was simply done to show how a motherboard with an I/O shield would be installed. The motherboard I will install does not have an I/O shield. However, before installing it, I personally like to install everything I can onto the motherboard first. For example, CPU, memory, and M.2 drives. It's generally easier to do this than trying to install them when the motherboard is in the computer case. In this video, I will only be focusing on installing the motherboard, as I will cover installing the CPU and other components in another video. There are a number of cables inside the computer case that plug into the motherboard. I will remove them from the computer case so I can plug them into the motherboard. When plugging in these cables, if you're having trouble working out where they go, have a look in the motherboard manual. You can see in this manual it shows the location of all the connectors. I also need to know the location of the front panel connectors. The information will be very useful shortly. The first connector that I will put in is the USB 3 connector. This is located at the corner of the motherboard. You can always look around the motherboard and attempt to locate the connector, but if you can't find it, look in the manual. With so many connectors on motherboards today, sometimes it can be hard to locate them. You'll notice that at the top of the connector is a notch. This is referred to as being keyed. This prevents the connector being put in the wrong way. It's just a matter now of plugging the connector into the motherboard. You just need to push it in until it's in place. If you find you're using a bit of force, you should stop and check you have the connector around the right way. You could also be attempting to plug the cable into the wrong connector. All the connectors are keyed, so if you attempt to plug it into the wrong one, you won't be able to. The next two connectors are the USB 2 and HD audio connectors. In this computer case, both are connected by the same cable, so I will look at them together. For your computer case, they may be separate cables. Computer cases will vary in what connectors they have, but these are the three standard ones that most computer cases have nowadays. USB 2 and HD audio connectors are not keyed the same way as the USB 3 connector. You'll notice that each has the same number of pins. However, one of these pins is blocked. The position of the blocked pin determines which connector it is. This prevents incorrectly plugging in the wrong connector or doing so upside down. You will notice that, unlike the USB 3 connector, on the motherboard there is no square plastic around the connector. When you see pins in a rectangle like this, they may be referred to as a header. Connector is also technically correct. However, the term header is more specific to a connector of this type. You'll find that a number of headers on the motherboard will have similar or the same number of pins. This can make it difficult to determine which is which. Motherboards will generally have printed next to the header what the header is used for. On this motherboard, there are two USB 2 headers. I will only use the first one. They both perform the same purpose, so it doesn't matter which one you use. I will now plug them in, starting with the USB connector. As before, you just need to push the connectors in. Just make sure that they're the right orientation and are in the right header. These two connectors will connect USB and audio from the computer case to the motherboard. The computer case generally has these connectors either at the front or the top of the computer case. Although this is uncommon, the manufacturer of the computer case can put them anywhere they want. I will next look at the front panel connectors. These connect the remaining items in the computer case, such as the power switch, reset switch, hard disk light, and power light. In order to know where these attach on the motherboard, you may need to consult the motherboard manual. Usually the front panel connectors are a group of pins, but on some motherboards they may be separated and not in the same place. Usually the motherboard will have printed on it what each pin connects to. For example, in this case, if you have trouble seeing, you can always use your mobile device camera to take a photo and zoom in so you can read the text. This example also has a speaker and chassis sensor. The chassis sensor is used to detect if the computer case has been opened. Both of these connectors are present on my motherboard, they're just not in the same location as the others. Don't assume that these connectors will be in the same place. The motherboard manufacturer is free to put them anywhere they like. The connectors on my motherboard connect to particular pins. It's just a matter of looking at the manual and matching the connectors to the pins. Each set of pins will have a positive and negative pin. When you are connecting LEDs, which are essentially little lights, they need to be connected correctly. If you connect them the wrong way, the LEDs won't work. In the case of switches like the power and reset switch, it doesn't matter which way you connect them since they're just a switch. Let's now plug them in. To start with, I will first plug in the hard disk LED connector. Since this connects to an LED, you need to make sure the positive and negative pins are around the right way. If they're not, the LED will not work. This connector is called HDD since traditionally it referred to the activity of the hard disk drive. However, nowadays it refers to any built-in storage. That is, storage that is directly connected to the motherboard, including solid-state drives. It will light up when the storage is accessed, including reading and writing. I will next plug in the reset connector. This connects to the reset switch on the front of the case. Since this is a switch, it doesn't matter which way the connector is put in. Because of this, you will notice that the connector is not marked with positive and negative. I will next plug in the power connector. This connector goes to the power switch. As before, as it is a switch, it does not matter which way you put the connector in. The next connector is the LED connector. This connector provides power to an LED light on the computer case to let you know the computer is on or blinks if in standby mode. It may also be referred to as a power connection. However, unlike the previous power connector, this is connected to an LED light, not a switch. Thus, the connector must be put in the correct way, otherwise the LED light will not work. This connector is different to the others as it is divided in two rather than being a pair. This is because in the old days, some computers used 2 pins for the connector, whilst others had 3 pins with an unused pin in the middle. To allow for compatibility between either system, the LED connector is separated into 2 so it can be used on either. This motherboard only supports the 2-pin power connectors. However, you will notice on a different motherboard, it supports 2-pin and 3-pin power connectors. If you come across a motherboard like this, you simply need to choose one or the other. It doesn't matter which you use as they perform the same function. I will now plug in the power connectors. Since they connect to the power light, the positive and negative need to be connected correctly, otherwise the light won't work. Once they've been plugged in, those are the last connectors for this computer case that have to be plugged in. There is, however, one more connector I need to plug in that's not part of the computer case. The last connector is the PC speaker. On a lot of motherboards, this will be located in the same place as the other connectors. However, on this motherboard, it is nowhere near the other connectors. In the old days, the PC speaker was part of the computer case, but when sound cards started becoming common, it was replaced by small attachable speakers like the one shown. Although you could use the PC speaker to play audio, the quality was nowhere near as good as a modern-day basic sound card can provide. Thus, the PC speaker only gets used nowadays for making beep noises. These beep noises are generally used during startup to indicate the computer is working or there's a problem. Also, the PC speaker is used as an alarm if a fan stops or the CPU temperature gets too high. For this reason, it's recommended to install the PC speaker. The PC speaker has a positive and negative wire, but will still work if you put them in the wrong way. It will sound a little different, but you'd have to have a very keen ear to pick up the difference. I would recommend putting it in the correct way. In the case of this motherboard, the manufacturer has provided us some printing on the motherboard so we know which way to put it in. I will now plug the PC speaker into the motherboard. It's just a simple matter of pushing it into the header, making sure it's oriented the right way. That's it for all the connectors, but before I can install the motherboard, there's one small problem with this computer case. This motherboard has the standard 24-pin power connector, an 8-pin connector and a 4-pin connector. The problem is the power supply that came with this computer case has only a 24-pin and 4-pin power connector. Something to consider when purchasing a computer case. Make sure the computer case has the required connectors for your motherboard. If the computer case is an older model, it's more likely to have less connectors than a newer model. If the computer case is very cheap, it may be old stock the seller's trying to get rid of. I will need to replace the power supply in the computer case with one that has more connectors. To remove the power supply, I first need to remove the 4 screws holding the power supply in place. Once they are removed, I will slide the power supply to the front of the case, as this computer case has metal retainers holding the power supply in place. Then I can remove the power supply from the computer case. I will replace the power supply with a fully modular power supply. Fully modular means that you can plug as many or as few cables that you want into the power supply. Semi-modular means you can plug in some of the cables and the others are fixed, whilst in a non-modular power supply, all cables are fixed. Since I'll only be looking at installing the motherboard, I will remove all the cables that are not required to power the motherboard. When installing a power supply like this, you are free to use as many or as few cables as you want. Keep in mind that if you don't use the cable, make sure you know which power supply it came from. Even power supplies from the same manufacturer can change the wiring around. The plugs coming from the power supply don't follow any standard. Thus, you may find a cable may plug into multiple power supplies. If the wiring is different, the voltage output will be different, and if you use them on the wrong power supply, you risk damaging any components you plug that cable into. To eliminate this risk, I generally plug all the cables in so there are no mix-ups. But in this case, I will only plug in the ones that we need to make it to understand what's happening. I will first plug in the 8-pin connector. You can see that the CPU is printed on it, but make sure you plug the other end into the power supply. I will next plug in the second 8-pin power cable. The process is the same as before. I will now plug in the 24-pin power cable. Often you'll find that the end that goes into the power supply is split into 2 different connectors. I will now plug both connectors into the power supply. Once they're plugged in, the next step is to put the power supply into the computer case. It's just a matter of placing it in the correct position and then sliding it into place. On some computer cases, it's possible to put the power supply in the wrong orientation so the fans are blocked. Always make sure the vent for the large fan, shown at the bottom, is not blocked. The last step is to put the 4 screws in the power supply. This will make sure that it is secure and the power supply will not move. As with the other screws in the computer case, they only need to be finger tight. Once in place, we are ready to put the motherboard in the computer case. If the cables are long enough, it's possible to plug the power cables into the motherboard before placing it in the computer case. Sometimes you may want to do this. In this demonstration, I will not do this because I want to use the cable management inside the computer case. To install the motherboard, I'll pick it up from the edges and place it in the computer case. You'll notice the drive bay at the back is getting in the way. I will need to maneuver the motherboard around a little to get it to go in. Once in place, I need to make sure all the screw holes are lined up with the standoffs. Once this is done, I can screw the screws into the standoffs. To start with, I'll put in a corner screw but not tighten it up yet. I first want to get the motherboard lined up correctly, and I want to allow it to move a little until it's in the right position. I will next screw in the screw on the opposite side. This screw I will screw in all the way, essentially finger tight. Once it's in place, I will screw in the opposite corner all the way. This will hold the motherboard in place while I screw in the other screws. You essentially want the motherboard secure enough so it does not shift. I will now tighten the corner screws up so they're finger tight. There should be enough screws in place to hold the motherboard in place while I put the other screws in. Normally, I will screw in all the corner screws first. However, with this computer case, there's a drive bay blocking one of the corner screw holes, so I won't put this one in. It's generally a good idea to put all the screws in. Make sure you have a good look around the motherboard because the screws holes can be a little difficult to see. You can see the last screw hole is under the drive bay. I can't get to it with the screwdriver. I could potentially use my hands to get to it. However, considering how hard it will be to get in, let alone get the screw out if I ever need to remove the motherboard, I'm going to leave it empty. Although it would generally be best practice to put all the screws in this example, it is more trouble than it is worth, so I'm not going to worry about putting it in. There are 8 screws holding the motherboard in place, so this should be enough. You don't want to make it a habit of not putting all the screws in, but in this case it makes sense. If you come across this problem, make sure you check to see if the drive bay can be removed, or in the case of some computer cases, the whole bottom tray holding the motherboard can be removed. For this computer case, everything is put together using rivets, which is a permanent mechanical fastener. Your computer case hopefully has screws which can be removed, or clips that can be removed to get to hard-to-reach screw holes. Before I plug the power cables into the motherboard, I want to do some cable management. Otherwise, the long cable may get in the way of the fans and other devices on the motherboard. To do the cable management, I need to remove the backplate of the computer case. To do this, I will turn the computer over and then remove the two screws holding the plate into place. Just for a moment, I will remove the anti-static cable from the computer. Normally, you would move it somewhere else, but there are no more screws that are attached to the computer case. So what I will do in this case is replace one of the computer case screws and attach the anti-static cable to this screw. I don't need to screw it in that much, since I will be removing it later, just enough so it does not fall out. I will now flip the computer case over so I can have a look at the cable management. Under the computer case, you will notice that there are a number of gaps. These gaps are designed to allow cables to be put through so they can run under the motherboard rather than on top. This allows extra cable to be hidden away so it's not getting in the way of fans and other components. You will also notice that there are some attachment points we can use for cable ties. These are used to secure the cable. Different computer cases will have different cable management systems. On modern computer cases, have a look around. There's probably something there designed to tie cables to. Just be careful not to attach cable ties to parts of the computer case that were never designed for that purpose. When we look closer, you will notice that the attachment point is just a part of the computer case that a cable tie can be threaded through. Let's have a look at how to use it. So firstly, I will stand the computer case up. This will allow me to thread the cables through the computer case easily. You'll notice on the motherboard the 3 connectors on the motherboard I will need to connect power cables to. These are the 8-pin and 4-pin at the top. Then on the right next to the memory module is the 24-pin connector. In the case of the top connectors, they are close to the power supply, making them difficult to get to. You'll find you'll have these kinds of problems with smaller computer cases, so often it's easier to buy a larger computer case. To manage the cables better, I will first pull the 2 8-pin cables through one of the cable management holes in the bottom of the computer case. I want to pull them through until there's a little bit of slack on the other side so I can reach the connector on the motherboard. I will first plug in the 8-pin connector. As the name suggests, there are 8 pins in the connector. It's just a matter of putting it in the connector and pushing it down until it clicks into place. These connectors are keyed, so you'll need to make sure that you put them in the correct way. When I plug in the 24-pin connector, I will look more at the keying since it's hard to do in this case because the power supply is in the way. The key is the same on all the power connectors. I will next plug in the 4-pin connector. You'll notice that the other connector is 8 pins. However, the connector can be split in half into 2 4-pin connectors. Once I split the connector, it's just a matter, as before, to push it into the connector on the motherboard until it clicks into place. Once both connectors are connected, you'll notice that the spare 4-pin connector is up against the power supply intake. With these particular cables, they're designed so you can split the cable apart, giving you more cable to work with. With the extra cable, I can put the 4-pin connector somewhere so it's not near the intake fan. On this motherboard, I've not installed the CPU and other components. If I had done so, I may have needed to put the 4-pin cable in a different place. If you're having trouble getting it to stay away from intakes and fans, you could always tape the cable to the other cables or use cable ties to hold the cable in place so it's out of the way. I will now pull the 24-pin connector through the same place that I pulled the other 2 power cables through. You'll notice that there's another hole to the left I could also have used. However, if I use that hole, it would block the 5¼ drive bay at the front of the computer case. Be careful which ones you use, as some are designed to help you access components, like the one to the right helps you make contact with the power supply to assist installing and removing it. Note that not all the holes are always designed for cable management. Some are designed simply to make installing and removing parts easier. You can see the 24-pin cable and the connector on the motherboard. When I have a closer look at the two, you can see there's a latch on the connector for the cable. When this is pressed, it releases the connector. For the connector on the motherboard, there's a protruding edge. When you put in the connector, the click noise you may hear is the latch springing back into place when it passes past the protruding edge. If you look at the connector on the motherboard in more detail, you'll notice that there are 2 types of pins. ones that are square and the other that has a chamfered top. These are designed to stop the connector being put in upside down. This is why you should never force these connections. If you're having trouble getting it to click into place, check that you have it oriented the correct way. I will plug the 24-pin connector into the motherboard. It's just a matter of making sure that it's oriented the correct way and pushing it into the connector until it clicks into place. All the power cables have been plugged in. I will next look at the cable management. You'll notice that the extra cable is not organized yet. I will lie the computer down and start working on making the cable a bit neater. Firstly, I will get a cable tie and put it through the cable attachment point. I will next make the cables as flat as I can. Once they're flat, I will thread the cable tie through the cables and pull the cable tie tight. You want the cables as flat as possible, as when you put the plate back on, you don't want it pushing down on the cables. Also, run the cables where there's a metal tray behind it. Try and avoid running over areas where there are circuit board. You don't want the cable potentially pushing down on a circuit board. I will now do the same for the 24-pin cable. Once again, I will put the cable tie through the attachment point. Get the cable as flat as I can so there's no kinks or twists in it. Once I've done that, I will tighten the cable tie and trim off the excess. Different computer cases will have different cable management solutions. This computer case does not have a lot of cable management. Some people will put a lot of work into their cable management, as in this example. How much time and effort you put in is all up to you. However, the main objective is to keep the cables away from components like fans and put them in locations that don't prevent airflow. Even with the small amount of cable management I have done, you'll notice how flat the cables are. I can put the plate back on, but before I can do that, I first need to remove the anti-static cable and the screw that I put in earlier. Once that's removed, I can now put the plate back on. Notice on the back plate there's a recess area. This allows extra room for the cables. But you don't have a lot, so make sure you get them as flat as you can. Once the backing plate is back on, I will put the 2 screws back into place to hold it firmly. Once in place, I will flip the computer over and have a look at what we have achieved. You can see how the cables look more managed. I could have pulled the cables through a bit more near the power supply. Cable management does take some time, and sometimes you may have to redo cable in order to get it just right. To understand how cable management can help, let's compare it with no cable management. You can see with no cable management, there's a lot of cable inside the case. All those extra cables can get in the way of airflow and also get caught in fans. Thus, it's a good idea when installing a motherboard to see what kind of cable management your computer case supports. That's all we need to do to install a motherboard. You can see why your choice of computer case is important. A slightly bigger computer case would have made the process a bit easier, but a smaller computer case also has its advantages. That concludes this video on installing a motherboard. I hope you found this video useful, and I look forward to seeing you in more videos from us. Until the next video, I would like to thank you for watching.